Let's have a look at question 4 from the quiz number 2, the revision quiz, and it says, given a simple random sample of size n equals 22, it's a normal population with a mean mu and standard deviation known. We test this hypothesis for mu is 3 and null hypothesis mu equals 3, and the alternate hypothesis that mu is greater than 3. If variance is unknown, sorry, so I thought we were given the variance up here, but we're actually not. The standard deviation is unknown, and the observed value of the test statistic is 1.94. Determine the p-value of the test. So it is a normal population, but we don't know the standard deviation, we don't know the variance, so we can't use a z statistic, we have to use a t statistic. And then we're told that the value of this t statistic is 1.94, and we're asked to find the p-value of the test, and it's a one-sided test. So we can just go look it up and try and find the one-sided value. Right, so I'm going to go to a t table now, and we've got we're looking for a value of 1.94. So here we are. So this is straight in our notes. It's like the second last page of the last page. It's called Table 4 Values of T Alpha, and we were looking for, I've forgotten the T value already, hold on, 1.94. 1.94 is what we're looking for. So we know that we had a sample size of 22, so it's 21 degrees of freedom, so it's this line includes the number that we're looking for. And we wanted 1.94, and that falls somewhere between 0.05 and 0.025. That's the alpha value for that particular score. So the probability of getting more extreme than a value of one of these two is going to be equivalent of that alpha. So it's going to fall somewhere between, the p-value is going to fall somewhere between 0.05 and 0.025. Can we get that exactly from this table? No. Well, we could interpolate, but we're not going to do that. I think if we get this sort of thing in an exam situation and you don't have access to some sort of a computer in order to calculate it properly, you would just need to give an interval here saying it's somewhere in that region. Bearing in mind this is one-sided values given in this table as well, so we don't have to do anything really more than that. So what we can do though is go to Excel and find out what the exact value is. It's easiest in Excel to use the negative value, because then you can use the t.dist function and go up to a value of minus 1.94 with 21 degrees of freedom and do it cumulatively, and you'll find that the p-value is actually 0.0329. 0.0329, and yes, that does fit within our range, so that seems to make sense that we've done it right, and that'll be our actual answer. So you just have to get used to looking up the values. So we knew the degrees of freedom, and we went looking for the probability, we went looking for the t value, the value of the t statistic that we measured from our sample, and then try to see what alpha value that equated to. So I hope that makes sense. We'll see you in the next one.